Okay, James, this is an attempt to try and explain the basics of the magnetic flux bit of the electronics option paper. You will meet magnetic flux in much more detail during year 13, and really to understand how a Hall probe works, which I think is the crux of your question, you need to understand both how an electric field works and how a magnetic field works. And we will look at those next year. But here's just sort of a sort of taster to give you the concept. So the first thing you need to do is remember the GCSE stuff that you've seen. So Fleming's left-hand rule, force on a wire. So if I've got a current going across my page from left to right, a magnetic field going into the page, to work out the force on the wire, I use Fleming's left-hand rule, first finger field going into the page, second finger current going left to right. So my thumb gives the direction of the force on the wire, which is upwards. Now, of course, remember that I've actually got electrons in the wire, and my electrons are moving in the opposite direction to conventional currents. My electrons are actually tracking left to right, but the force on the wire is upwards. Okay, so now let's put a semiconductor in there. So once again, I've got my B field going into the page. I've got a little block of semiconductor there. I've got my current going left to right, and I've just drawn on a few electrons. Let's have those electrons to start with going the same way as we did before, because my current's still going left to right. So I've got my negative electrons that are actually tracking across like that, but they're going to experience a force. They experience a force upwards, and so I'm going to get a build-up of negative electrons all the way across the top. But that then means that I've got these negative electrons across the middle, and a pile up of negative electrons at the top. They're going to repel. So these electrons are going to experience a force downwards due to the electrostatic repulsion of the electrons on the top, as well as feeling a force upwards due to the magnetic field. And at some point, the two of those will balance. I can use a voltmeter connected across the two faces of my semiconductor to work out what the charge on the particles that are lined up across the top are. Because of course if I've got negatives piling up there, that's going to be different to if I had positives piling up there. Okay, that's a very brief summary of what's going on. As I said, you'll see it in much more detail next year, and I think it becomes a lot clearer to see exactly how it works once you've met the equations, but hopefully that gives you a flavour. Okay.